I suppose we can start. Hello everyone. Let me just verify whether everything works or not. I know I'm doing these streams on kind of late notice. I suppose since tomorrow we can have a more structured schedule. Let me just verify whether things work here, whether you guys can hear me. I can see my OBS is running. Let me just briefly validate things, and I suppose we can start. What is happening here? Where are my videos? Just give me a second, guys. Need to make sure you guys can see me, hear me. If you could put something in the chat, maybe it's going to help somewhat. Where are my videos? Maybe I can just... I've already pasted this on a LinkedIn. Maybe a few people would join. But I need to know whether the recording is actually working. Yeah, okay, so we have some delay. That's just normal for a stream. That's cool. Okay, hello everyone again. And today I want to focus on the Gatling plugin for load testing a Kafka integrated application. And the difference between the Kafka integrated application and the Kafka system is huge. Most of you, I get these questions coming from you on how do I load a Kafka system. When I dig deeper into your requirements and your expectations of the load test, of the in-test result, you actually want to see how does your application, so on the other side of Kafka system, behaves when it's connected to Kafka. So it is similar, somewhat similar to the say load testing a load balancer, right? Speaking of the HTTP protocols. So you don't usually load test your load balancer, you rather test the load balancer, so hit the load balancer to see how your application is going to receive the load. And the behavior of this application might be a bit different. Most of the plugins that I've seen were actually focused on load testing the Kafka system and not the application that is integrated with that. The difference is huge because you usually don't have the context of your business application when you are running a load test that you know are actually expecting some responses. You know, it is hard to verify and to measure the latency from your customers, especially when you have some system-oriented architecture, when you move through the pipelines, when the application has to match the request with the response, but it ultimately affects your end user. This is where things get tricky. So I want to focus on a plugin that can actually measure the full end-to-end flows. Again, one of the things that already exists, this is plugin by Pavel Bayrov. He's done a great job when developing this plugin already, but it has a few drawbacks that you have to be also aware when you are running a test on your own. Guys, you can also say something in the chat. I'm gonna see if I can see your comments here. Say hi in the chat. And I need to verify whether I actually see your comments here. And I guess I don't. That's a bit weird. That's a bit odd. No, okay, it did pop up here, but it is a bit small on this screen. Okay, let's see whether I can Oh, now you should hear me. See, there was no audio, and I was talking to myself again. So I did a bit of apologizing. I'm not gonna do it right now. So we can start and verify what I have been working on. So I did some common coding in the background. I did some validation of the stuff. Can already see that the screen that I'm sharing with you guys, this is somewhat cropped, so I'm gonna have to fix that as well. Just found that this is it's not this one. Nope. So I'm sharing some screen, and I think this has somewhat limited. Is it this one? No, it's not. There's the screen. Okay, I think I know what's going on. I'm just gonna have to scale it somehow here, like that. And you guys should see that as well. Okay, so covering the topics and most importantly, the user experience on how to develop those tests. This is something that, when you pick up some tool, when you pick up some framework, some tests, you need to be able to understand what you're actually doing and what is the entry point, and this level of entry should be fairly easy for your target audience. I know that Gatling is a tool that targets mostly developers, so they should be fairly familiar with the code they're producing, but also, there is a lot of people, a lot of folks from the testing community, performance testers who come from the tools that have done most of the job for them, and they have little or no development skills. I know that my shirt says here that software developer. I actually have never worked as a software developer myself. It was mostly on the QA area, but still, I think I can have some sense here and something to say. So the idea here of the plugin here, and this is specifically for the request reply. So I'm expecting a synchronous response from the application after some time. The idea here is that I put the what I want to put my message to, what I need, what I expect my response on. So this is a standard, say, request reply. Like you put some requests on one topic, and then usually that is somewhere in the headers of the message, you put where you expect your response on. Then you have to provide some ID of the message. This is the ID which is going to be the key for the message. This is how most of the application would recognize the message. That's the first thing. And if you once you produce the message and and expect the response on, this is going to be key, that both the requesters, so both the clients and the server, would have to copy over to make sure that this is your key and this belongs to this particular message, right? When you have a stream of messages, you have to be able to pick up and match somehow and map the request with the response that you have sent. So that's a very very interesting and very important part. Pavel's plugin also supports matching by some value, so it could be somewhere in the body of the message, right? This is something I may consider actually adding also, because not the keys in the Kafka protocol, they are not guaranteed, they're not mandatory, so you can put a null value there. The behavior of a null value would be slightly different than with the key ones. So the key of the message in a default producer determines the partition that the message would land on. So and the distribution between the partition makes a big, huge difference. So right now, I'm assuming that all of the matching will happen over the key of the producer record, right? So when you have a producer record, so it's going to be producer record, and it actually goes with, like, I don't know, this could be any type, right? So this could be object. Typically, it's going to be string, and then some value like object, right? So and then this producer record here, this is going to be the key, this is going to be the value. So effectively, later on, when you have a consumer that pulls the message from the topic, you will have a list of those. So each of the polling transactions will return a list, so at least one of the records from a poll. So we're going to touch on that later. Again, the details required to get the message and to send the message. First, it is the key, and then there is the value. Right? I've played around a bit with various object types. So I've added two new ways to send the message. One of them is a plain string, so you can set a string value, and this is going to be serialized into byte underneath, but still you can send the string values. I've also added support for the protobuf. So this is also a common way to send messages to the Kafka. This is something that I had a chat with Pavel and also said that this might be something worth adding. So it's already there. You can just build your own protobuf message, and this is my whole message right here. So I have a builder of my message, and then I specify how I want this serialized. The reason I also put this serialization type is because I am serializing and I'm persisting these requests I'm sending in a database. So my choice right now is a Postgres. So I also want to be able to specify the type that I want to serialize on, because I will be extracting also the request again that I'm sending, and I will be matching that and running some checks. So this is something that, like, I have not seen anyone doing yet. So this might be something that may be beneficial. And then there's a list of checks. This is something that I know that when we're talking about the assertions, there is a common misconception that assertions are somewhat expensive, and I know I have been one of those guys that also have advocated for the least amount of assertions inside a test. Because of their cost, right? So when you stock up, let's say, I'm gonna use some examples. It's a terminal. I'm gonna open up a Gmeter, and I'm gonna tell you what I mean. So I'm gonna show you some of the examples of bad assertions. So let's say I have a task plan and I have some thread group. This is going to be fairly straightforward. I'm going to add some sampler, HTTP request, right? And then I want to validate some assertions. I want to run some validations against this object, right? So I got the assertion here. I want to match some response assertions. I want the test response, patterns, substring, whatever, and I can just do success. Right? So I want to verify that this guy has a success, right? But then again, and I also want to verify like some JSON element in this case, right? So assert this not validated that for a long time. JSON assertions. So I guess you can add the JSON path here. So JSON like ID like of a value 3, whatever, right? So here, right? And then I have 2 assertions already for the same object, right? Then again, I'm gonna add some, I don't know, XPath or I think a regex assertion would be the most common one. So it doesn't exist. I think it's going to be response assertion only. Yeah. Okay, so it was changed to the response assertion, but you get the idea. So when you want to validate a few objects, a few things from the same response, you have to stack up those assertions, and the cost of these, for every single one of these assertions, you have to parse the same object. You have to still run some checks against that, and then return some assertion result. Right? The assertion itself is just an if statement. It is just a simple comparison. So, hey, does this equal this? And most of the compute power coming from these assertions is really embedded into how these objects are serialized, how that they have to serialize it every single time. So you have to copy this value. You have to serialize into some structure that this assertion type supports, right? And then you have to run some validation, and you have to do it for every single value that you have, right? All of these assertions are somewhat limited to a single assertion check. What I am doing right now to somewhat mitigate this problem is I'm forcing only one assertion per check. So if I have a check, for example, for my proto checks, I'm actually using the same request check because I am cheating right now with my tests. I'm sending the messages to the same topic that I'm reading from, but that's okay. This is just a formality because I don't have any application running in the backend that can actually respond to me yet. I do, but it's not on. But it doesn't matter. So I have the request check that has a list. That is a list of validations that I'm running every single time, right? So I'm specifying how I want my request and response to be deserialized, right? And once I have those, the system will automatically deserialize them once, and I can run whatever assertions I want, right? So in here, I can validate just the response of just the request. So hey, I'm checking if the request is null. I'm checking if the response is null, and I can also validate whether some application, whether my request ID equals to the response ID that I have received, right? This is something that I have learned when dealing with the asynchronous systems. They are more prone to errors originating from a race condition. This is something and I've seen it a few times too many to neglect this option. So this is why I'm introducing the validation of the checking the response, not only for a response for a successful one, but also whether it belongs to the customer that has sent it, if that makes sense, right? So not only that this consumer had receiving the response, the successful response, but also whether this consumer actually, whether this response belong to the consumer that has access to it. This is extremely important for a very sensitive information. So when you are running some, I don't know, some financial stuff or when you're processing some personal data, this is something that really makes a difference, right? And we're talking about some GDPR fines because I don't know, you have some race condition there, and suddenly your customers see different data that they requested, and they see somebody else's data. This is probably most most concerning. So for this particular case, I have an option to deserialize the request and the response, so you have access to both at the same time, and you can run some validation to make sure that you're actually getting the data that the customer should be getting, right? Most of the plugins that exist there, they only do the validation of the response. So something that I wish there was improved. Okay, how does this work in a backend? It has a few perks and few Um, it has a few features that I've worked on. First of all, sending the message and getting the response. This is mostly asynchronous, and I wanted to feel it like a breathing for the user. Main option in specifying the protocols and specifying uh, the, the things for the customer that is nowhere to be found on the existing solutions is specifying the number of producers and specifying the number of consumers. This is very important when you want to run a distributed test, but also number of producers and number of consumers define the maximum throughput of your processing. Most of the plugins, they do have one consumer, one producer. The worst tests that I have seen that were working with Kafka, the worst cases was that for every single message sent in the to Kafka system, the user would create a new consumer, right? This is a killer for the Kafka system, not exactly how any application would work. So when you have a consumer, when you have a producer, each of a producer and consumer has a separate network thread that is pulling from or pushing to. And this is important to make sure that you only have a set of producers, set of consumers available all the time. The consumers, the behavior of the consumer is totally independent of the data that we're producing. And as you can see here, I have not fixed it yet. For first, I'm waiting for around a minute to synchronize the consumers that I've created. This is something that, when we are creating the consumer, you have when they even subscribe to some topic, they have to connect to the topic, they have to connect to the brokers, they have to find each other, they have to rebalance, they have to form a consumer group, they have to get some metadata downloaded, and it takes time. Even when you're not pulling the messages, it still takes time to get them done. I have not yet implemented any sort of synchronization mechanism. That I think that it must be some call out and some callback that I can use to make sure that these consumers actually have spawned already. Right now, I'm just waiting for a minute. This is something that is like probably this probably requires some synchronization from my side, and then I'm starting a ramp up of my users. The user in the context of a synchronous request from in the Kafka perspective, the user only generates a message and then just dies. This is something like unlike the web user that you have, and they are performing some actions on the backend, and they just scroll the front end web page, they click things. Most of these messages, they are just one time off, so they just send the one message, right? You could make the user execute a few messages at the same time, so this will be slightly different then. But most of the systems I have worked with, they would only be independent messages, right? There is no context of a user. There's no context of a session, and like a standalone atomic message is enough for the system. You could, however, extend that and then just add a new message that you're going to be sending. This is something that is totally possible. One thing to understand when you are sending messages to the Kafka system, and this is something that I have implemented here, I don't wait for the response here. So this user actually, as soon as it produced the message, it has sent it to the request topic, it is gone. It doesn't wait for that. The rest of the mechanism will happen in the backend from the application side. So the not the application, the load generator side. The load generator would handle all of the measurements, so it would just store the request that I have sent when is it expected to time out, and then run some checks and validations later on to see that the message actually had expired or not. Right. So in case of a timeout, I want to have a real-time updates of the timed out message, and this is something that I want to keep from the user. Like I want the user to actually wait for this message, but I also want the tester to be aware that there were some timeouts happening and there were some failed checks because of that. So right now, this is how it's done, and the consumer, well, it just consumes the message and then tries to, like, this is the initialization of the consumer. It just subscribes. Each consumer actor is acting as a one consumer object, so a Kafka consumer. So it is just going to run in the loop like indefinitely until we have hit stop a test, or the user has been signaled to stop the test, and it just closes the consumer. It just consumes indefinitely over some interval. I think this is currently hard-coded. This is not a good idea. So I'm going to change it as well. But in overall, it's going to continuously pull the messages from the topic that it was supposed to pull from, and then run some processing. The processing, this is the core of the logic. This is the process record. The processing also happens asynchronously. This is the producer actor, so you have to find the producer record. This guy here. So for every single message that I'm receiving back, so for every single message that I have consumed, again, this has to process all the messages. Now I have some issues right now, and not an issue, but I'm trying to scale this up a bit, because right now the only really reliable source of information would be to store the messages in memory. This is limiting the whole solution, because the whole solution right now is is constrained to a single load generator. Now, if you are using a standard license for Gatling, you are already constrained to a single user. But if you want to use it on a bigger load, if you want to use it on an enterprise scale, you're going to need some way to distribute these calls and to distribute this processing of the messages. So this is very important for the users, and very important for the consumers to be able to process and validate the messages at scale, which is not possible if you only store the messages in memory. You have to have some third party or some independent storage that all of the workers can access. Otherwise, you're gonna land into a realm of duplicate messages when you will not catch them, because, well, if all the messages have if all the consumers have their own dedicated memory, it is hard to keep track of the quality of service, which is also something that is often neglected when it comes to the analysis of the test rank part. When you just push the load to the system, and if you just run a check of, hey, how many messages did I send, how many were processed, you might be running into a trap of actually having duplicates of messages and errors from the backend. I've seen it happening, so this is not something that I just came up with because it might be a good feature. This is actually some problems I had to solve in my career. So that's why I'm building it like as much as I can, so that the tester would focus on problem solving and not validating, hey, the Excel sheet that the or like in search for some trivial problem like where all the messages processed, right? This is something that you will get into when you are running a test with either using MQ system or a Kafka system, and it's hard to debug, and it's hard to map that if you don't have a party that actually is focused on this particular problem. Okay, just quickly validate what is happening here. I think we have 2 watchers right now. Okay. So, guess we can start. Guess we can start then with some development. Trying to open here. Oh, this keyboard probably is. I'm gonna run my script right now. I'm gonna see whether I can open the Docker. So I'm gonna have to start my Kafka topic. I'm running a bit of shortcuts when it comes to the architecture and the and when it comes to my application itself. I have a very simple Postgres running and a very simple broker. My table is actually not optimized for this kind of load, so I will probably run into some profiling because I know that there are some huge differences when I run this on a distributed setup or when using the Postgres DB. We are going to start first with an in-memory message, so I can show you that we can easily get into a 10,000 TPS of messages, and that's nothing for the system. But it is going to be slightly harder to get to the same levels when using a Postgres for my storage. So I am going to start with some okay, so Kafka protocol request store. I can specify where I want to store my request. This is something that I, again, have mentioned that is required to get the matching between the request and response. This is something I have not thought of yet, which is probably the most basic scenario that you just want to push some messages to the system and not to store them. I guess I'll have to come up with some dummy storage system that doesn't return anything, that doesn't store anything, some kind of no-op storage for the fire and forget messages. This is something that is probably going to require some of my development, but that's fine, I guess. I don't think it's going to matter that much. Okay, so we can start terminal. And is that how we write? Is that, no, it's not test Gatling, it's Gatling test, right? Okay, let's see how this thing works right now. Again, I'm doing some, I'm taking some shortcut right now because I'm sending the request to the same topic that I'm reading from. This is just for my own comparison. I don't want right now any third parties to I don't want any third parties to affect my own. This is something weird. Hold on a second. I should not be getting correlation errors right now. Why would they pop up here? Something weird. Huh. Something unexpected happened. I just have gotten like 21 requests, data not found for a certain correlation ID, but I'm using an in-memory store, so this should not be happening. Huh. Kind of weird. And totally unexpected. We can debug that later. That's fine. Let's just wait until the... Okay, I'm starting the messages here. You can see I'm actually getting the Kafka request reply action. This is also using the akka actors, just like the Gatling built-in users. So this is a lightweight form of user. Like unlike the Java application, which uses the system threads, the Gatling uses akka, which is an implementation of a it's like greenlit threads or lightweight threads. They things that only reside on the memory and share the common pool of threads from the system. So it is harder to manage the memory on these objects, but they also there is no context switching happening on the system levels on the processor, which is like for load like that, it's beneficial, highly beneficial to achieve. I'm not sure why I'm getting this 21 error not found for the correlation. This should not be happening with the setup I have right now. But after these errors have occurred, I'm guessing I'm getting only the positive one. I know what happened. Okay, I know. Probably, and this is not related to the store that I have. Although, if I had I been connected to the Postgres, I probably would have captured that. The correlation ID, they belong to the previous test run that I had, and they were still on the Kafka topic. So whenever my consumer, like once my consumer had connected to this topic, they have pulled these 21 records from the response topic, which is why then later there's a logic to verify, hey, do you actually know this request? And because I'm using a brand new in-memory store, in-memory cache, the answer to this question would be always no. So this is something that I also probably have to look into, whether I have to sign the request with some ID of a test run. So this is something that's I've like not seen in a tools like Gatling or JMeter to sign your test run like with specific ID anywhere. But I would find it most beneficial for many cases that each other sampler would have its own unique test run affiliated with that. So then I can have a distributed test of maybe many tools producing, some sort of same values. Let's say I want to have Gatling load test my Kafka, whatever, and then have some other tool that load test something else in the same time. Because some of the things are good with one protocol, and the other tool might be good with some scripting or some checks. So this is something that I would find the most beneficial if I could just have the same common test ID for any of these tests, and have a set of distributed agents that can stream my data somewhere into one of the tools. Okay, the test is still running. I ran over 1.8 million requests so far. One of the things that okay, the test is just done, so I can open it. Let's see how it behaves. Mean throughput, it's 6,000 TPS. That is not bad. I'm running everything locally on my old M1 MacBook Pro. I'm saying old because it is over 5 years old right now, and I think close to 5 years old for now. but it still does the job well. I'm also locally running a Kafka on my own Docker system, and the same for the load generator. So everything is running locally. I'm using up to like 60% of the CPU for this kind of load. So having an average of 6,000 TPS for the whole test run is a good score. Let's see how this system behaves later. Whether I can. Okay, let's see. This is my LinkedIn page. No self-advertising here. Okay, going back to the main subject. So you can see here, this is my set of requests that I've sent. 1.8 million of the requests. It is capturing also the idle state. So the count per second is also going to count the wait times. So prior and past the execution of methods. Max time you can see here is reasonable. It is like 500 milliseconds. And users easily, I'm getting easily up to 10,000 users on my local machine. So this represents a 10,000 TPS of loaded requests. This is something that I find reasonably okay for most of the applications you're going to be load testing. And the same here. So the response times, percentiles, there was some spike here, but they would all be related to the latency of my own Kafka system, right? This is nothing crazy. It is like the response times, again, the full response time in this context, since I'm sending the messages to one request topic and also polling the same request from the response topic, the latency consists of only a single leg of my transaction context. So I'm measuring here how long does it take to send the request and to persist it on a topic. Then it comes it is also including the replication, so replication of the topics, and then again I have the consumer, which is also running some poll, and so I'm also including the consumption of the message. And once the consumption has started, I think I'm persisting the timestamp from there. And then I'm processing the messages, processing the response asynchronously. So this is what my measurements currently consist of, and you can see here, it is fairly fast. The 95th percentile is up to 35 milliseconds, 99th goes on to 100, maximum goes on to 555. The percentiles here, they play a role, like there's many factors in this in my configuration of both producers and the consumers that add up to the maximum percentile, right? So it doesn't mean that the Kafka topic is so slow you're going to have like latencies of magnitudes of 100 milliseconds, but there are some configurations due to the nature of both the producer and consumer that your tail latency would be skewed by that. So mainly from the producer side, there is a linger property that tells the producer to wait until a certain time before it sends out the batch. And the batch is the primal and the most atomic unit in the whole Kafka topic, right? It doesn't operate on messages. The producer sends the whole batch of messages that he had received in a certain time or a certain space. This is also one of the conditions here. This is why it's important that we have some and that we have some distinction also on what belongs to the customer, so what belongs to the producer, what belongs to the consumer, and what belongs to the Kafka topic and what belongs to the application. This distinction is crucial for any type of RCA, root cause analysis, that you're doing, because you have to be fairly certain that the latency that you're seeing belongs to a certain component, which is not easy always to determine, even if you see some numbers, some volumes. It is not always easy to determine what exactly component is the culprit of your increased latencies inside a synchronous system. Right? I've seen it many times happening that some of the application was blamed for, I don't know, not picking the messages from the topic, where the culprit was either on the Kafka topic itself, so on the broker side, or it was like somewhat affected by the producer itself. Let's say, for example, sending a transactional message, so it has to be in the transactional context. If the message is not committed and the isolation level on the consumer side is looking for committed, from a topic perspective, the message would seem like it was put already on a topic, and from the consumer side, it would look like it had not picked up the message, where in fact the message was just simply not committed. Troubleshooting of this problem is a bit hard to understand. You'll have to actually go and check the transactional topics, which are also a separate context. But still, this is something. Latencies in the Kafka realm, they are a bit complex, and you have to understand the nature, the asynchronous nature of this behavior. You have to understand that the producers and consumers, they are fully detached. They don't depend on each other. No customer is stealing the messages that would disappear from the topic, etc., etc. This is something that takes time to fully understand before you actually can run into some meaningful analysis of your latencies. Okay, so this simulation works fine with my in-memory store, but when I change that slightly to my Postgres application, this is where the things would start to get messy, and I will probably have to even change the throughput of the application to tell you that it's going to affect the whole application. I know that with a 10,000 TPS, it is not going to cut it. I will probably have to do some troubleshooting into what exactly is the problem. I'm using the Hikari for the connection handling of these messages, and also if I look into the request store, these transactions are fairly straightforward now. So a selection of the request of a single request is this one here is just a select here, and it's a select for update, right? So it's a lock level, row level lock, sorry, which means that if as long as you have a for update statement and you have not committed the transaction, this particular row, so this particular transaction that I'm storing in the database will be locked. So no other application could access it on a committed isolation level. You could do a dirty read from the application. I don't do that, so I'm locking effectively the whole record so that no other thread, no other system can access it at a time. The reason why I'm locking this whole message is because I want to make sure I don't have any duplicates. So it is a possibility on the system that you, for example, that either the application or your producer would produce duplicates of the same message, and this is a factor of the quality of service that you would run into, that you want to mitigate somehow and validate and prevent duplicates of the messages. unless your system allows it, right? But in any case, you still want to be able to determine how many duplicates you have and whether it is an actual problem for you or not. So again, this is something that that comes back to the database handling. So select for update, and this goes here. I'm actually, okay, I don't fully utilize this right now though. This select for update, because currently, and this is the default behavior of the Hikari thread pool. The standard connections come with a auto commit enabled, so every single message gets immediately committed, right? So even though I have this specified right now, this is something very important. I'm gonna be fixing that in a moment. So this for update doesn't actually do anything. It just locks the record on the during duration of just the retrieval, right? Typically, what you would want to have is like for this sort of operation, you would want to have a select for update, and then do some processing with that, and then delete where ID is this, whatever, right? So I need this here. So this, and only then this record will be available for any else, right? One of the other things, the for update, actually, this could be also a skip locked. Once the message is already locked, you can actually skip that. A select for update will try to lock the record, and the connection is going to wait for this record to be available. So this row is going to wait indefinitely, waiting for this particular record to be available again, right? So it waits as soon as the first thread acquires the lock with the for update, and is going to commit that. It's like my logic first would be the first select, and then the delete. But you can also do the skip locked. So effectively, if you find any request like that, you can just, and it is locked currently, you can just not wait for it, right? And it is going to be also a mechanism for me to optimize the connection, but also a message that, hey, something else is already processing this message. There is something wrong. There is some process that had captured first, and probably has the first probably is the first to process it. Okay, so moving back to the Postgres processing, my first task had finished. Let's see what the latencies look like. I'm running at the top of 1000 TPS right now. You can see here that the percentiles differ a lot. You can see also that the number of active users over time had like changed dramatically. So I cannot even spawn the users that I want because something is blocking my my simulation. Also here, the max time and the percentiles, the response times, have changed dramatically over time, right? This is where I'm getting the response back. And the users have just stopped at this pace. Number of requests per second, something I've seen that is very weird for me using this context here. If you see that here, if you see that the number of requests matches the number of active users, with Postgres, after 2 minutes, the number of active users stays the same. Like for another 10 seconds, it's at like 30, 40 seconds. The number of active users stays the same, but number of requests not. I have some bottleneck here that is preventing me from running the full load for whatever reason, right? So I cannot even achieve 1000 TPS right now of a stable throughput, stable load from my side. So this is something that I'm going to be working on, and I'm not even sure yet. I haven't chosen the way to profile this test. The thing about this Gatling test and profiling it's somewhat tricky because well, it is invoked via the Gatling Maven plugin, typically. And this might be a bit problematic to troubleshoot it. So I'm thinking maybe some sort of profiling tool. Like you cannot just plug in the open telemetry and expect it to work. This is something that, although you could, of course, instrument it yourself, this might be an option. But I'm thinking maybe some profiler, some continuous profiling tool could do some help here, because I don't know right now whether I'm waiting on for the available connections. Maybe I don't have enough connections in my pool. Maybe these requests are just too heavy. I don't have any index there. I don't have any partitions, so the selects, they will be heavy for sure for these particular connections, even at some low TPS of of 1,000 TPS. They may still be too heavy for this database, so I can have some delays coming straight from a database. Right, my best guess for now is that I actually have some. I would have to add some indexes, or indices for this table to make sure that I only process what I want. And also, I could be running into some problems with outstanding requests because I don't clear those after the test. So there might be some way right now that I have too many requests on the database stored, and this, yep, this looks like it because I have stats. This is my current test that I ran. No, there are even some old tests that I had like in the July 2nd, and I guess I should be including some mechanism to clear out those outstanding requests. This is something that I think I've started working on, but have not finished. So currently there is over like close to 1 gig of data stored in this database, and there is no index currently on this table, as I know. So we have to work it out and verify that we have this data. So I can just truncate it. See how it behaves. Okay, is it committed already? I suppose it is. Can I just refresh? Okay, now it's blank. Let's see how this application behaves. Because if it's only the index, then it should be fine. Then it should not be a problem. But I guess that is also something else there that is blocking me here. So for now, the extraction of those requests happens one by one. This is also a bit problematic from the perspective of the of a database, because if you then somewhat counter intuitive and counter the behavior of the Kafka batching. So the consumer actually pulls a batch of messages, and when you start to extract them and process them one by one, you end up with like n number of queries for every single message, right? This is something that is not like reasonable to do when you just want to measure and assert the application, the transactions. You can limit the number of queries by by batching these requests by batching these requests together. So just gonna have to So the idea here is, and this is something that I had to play around with for update statements and for like in requests. I even tried to maybe make the Gemini modify the script a bit, but it doesn't, like, I've crossed some limit of the context, so I guess I'll have to just do the manual work and verify that maybe this also right, manipulating a transacted context inside the actors is a bit problematic, and it is challenging in many ways. So and I don't want to introduce any third-party like plugins or frameworks to do that, to handle it for me. Like the thing, if you look up any recommendations for managing the transacted context, the first one to pop up will be the Spring and some Hibernate frameworks. I'm not sure how well they actually integrate with the Akka actors. And the challenge of containing a transacted context inside an SQL is that you have to persist also the connection that have started the transaction. So you have to pass around both the connection and keep it in the transacted context, and then you have to maintain the commits or rollbacks. So this is a bit of a challenging here because I won't specifically do the first select and do some processing and then do some delete. Maybe I could get around with just deleting with returning the data. Maybe, but I'll this actually may not be a bad idea. There is a returning clause in SQL. I'm not sure whether it works in the Oracle. Sorry, not in the Oracle, but in the Postgres. SQL it works, Oracle it works, DB2. Yeah, okay. So this is a good point. So maybe instead of what I type in here, so I have to get a more comfortable position for me to sit. Maybe instead of changing the maybe sort of selecting the rows. So this here is like okay, this expired, it's fine. Maybe instead of selecting these for updates, git log, whatever, I could just delete those if they exist. This is an interesting problem. I'm gonna have to think that through. Right? First, my idea was again do the select for update, and then process this thing, whatever. So throw all the errors, whether they've been matched or not, and then so for update process, and then delete where blah blah. Right. This is something that is doable. However, to maintain this in the code, and it has to be a pretty code, I'll probably have to do something like this. So starting the requests here, this goes with get requests. So void match. So this is my interface for all the stored requests. I want to support a batch process batched records. right? And this is something that like this going to contain a list of. Do I need a list of objects of a matched request? I have to do that. Yeah. So this is just getting might be a tricky one because the process batch record is going to be invoked by the Kafka consumer actor, and so this guy gets the consumer records. Okay, but it's just a string and bytes. That we can live with. And then we can just pass around all the records. Yeah, I think this is going to be good. We can just pass around here the consumer records, all of them, and then process them asynchronously. I think this could work. So again, back to the interface, we're gonna have a custom, whatever we've pulled from the request, these are going to be records and not the, I'm not sure they want to constrain these. I just going to have to go with map. I don't want to constrain this interface to the Kafka only, because a similar mechanism can be used for, let's say, MQ processing, for example, right? You can also batch some MQ messages at the same time and process them. So this might be a beneficial one. Okay, so by records, and also on top of that, since I want to have a first select process and then delete, this is where I'm going to need some processor batch processor. Process. Batch processor doesn't exist, so I have to create that, and this is going to be an interface. Doesn't belong into the cache, belongs probably, oh yeah, probably does. Okay, so it does have a void. And then it has to go with a second, I have to think of the types here. Let's go with the requests. I'm gonna have to add everywhere the method I have just created for my interface. What do you guys think? Maybe I should be just using a Copilot or whatever. I actually have one of the tools that I was invited by, and I had a meeting with the guys from, one guy from Windsurf. They have granted me access to one of their enterprise IDEs. I have not started yet though using it, so it may be a good thing to start. Okay, but then again, we want to have the Kafka consumer actor, see how the processing works. So it does the processing, process of the record, and with the end time. The end time, however, what was that? Oh, actually, I don't have to do that. Okay, so this can be this process record. This can just implement the Kafka messages, process record. This can just be my interface, right? Yeah, it can, of course. Mm, SAM batch processor, is that correct? Quick fix, okay. And I have to change that to a process record, but this is, no, this is a constructor, so I cannot just do a, no, there's something wrong here. I've messed up a big time. But because this is a class here and it just consists of the process record, messed up big time again, there's something wrong here. This is the processor actor. This guy should have a process message. Okay, now it makes sense. So this just accepts the process record. Now it makes sense. I was kind of blown away about that I could just type a method like that. So this should not be a process record at all. The message processor actor should be also a batch processor. And then you should accept the batch processor should also get the process record in here. And I have to import this type here. This is a weird feeling, getting somebody code and type without any AI thing here. I think this looks okay. So I'm going to pass this message processor actor method. Should I think, how's this thing message processor actor passed around? This might be a clue here, because I want also to be routed, for those messages to be routed effectively. Okay, this is a private method. This cannot be invoked here. This goes with the create receive message processor actor. I want these to be processing the whole batch because I need these to process them, of course. But I also want them process like this. This is something that I don't fully understand yet, how the Gatling manages those, and I think it's just related to the actors. So here, like creating the router for these message processors, this is something I don't think I've fully understood yet on how they work. And to make things more interesting, I actually have I'm coding this in Java, which is not the native language of this framework, right? So this is something that might be somewhat limiting me, but I don't think it's going to be much of a problem. Okay, see here, this is my processing here. I'm creating the process record of that, and this is the tell thing. So message processor router, and this is actually the method I should be actually forwarding to. So this guy should have a process method that is just dispatching the processing later, and after that it can do anything it wants. might make sense. So like this part of message, this part of the method could go into a single one with accepting the message records and the end time. So the polling time, this makes way more sense. Other than this interface to be implemented here. So this logic I want to be a part of a executable. So I want it to be a possibly some, I don't even know what it's called, some anonymous interface implementation. So just with an overridden method that this is going to be my process method, and this should be fine, I guess. But then the Kafka consumer actor, they should have access to the store. The Kafka consumer should be aware of the store, because right now I want to effectively make the batch processor. Okay, this goes with the process. This here, this effectively, I think I'm breaking a few rules of the programming here. Process record, go away. So this batch processor process records, this is fine. And then when I have, for example, a Postgres request store, and this should have a method implemented here for the process batch records. As records here, right? That should be fine. You know what? So I'm gonna have to do some select here. Somewhat like this. So this guy goes here. I need to first get the collection. This might be more complex than I thought, and this is definitely not for a 1 hour stream. And I guess we can tackle that. I don't think it's gonna be a problem. So I need the selection, I need the correlation, any, and expired false. I don't think the expired field actually belongs here anyways. Should be fine. Okay. This is my select here, and I will pass the map of the request strings. This is a mapping of the connection here. Again, the order of these operations will have to be very precise. So I'm gonna have the data source connection. Okay. Okay, and then finally, just gonna okay, the first thing I want to set our commit to false. This is something that that is going to allow me to run two two things in the same transaction, like in transaction context. Otherwise, all of the transactions and all of the queries that I'm going to be executing will be atomic. So I want to avoid that, and the auto commit is going to be set to false. Then I need the transaction isolation. It should be okay. Now every transactions should be fine. Do I have to prepare a save point? I don't think I have to. Okay, so this goes auto commit false. That's fine. I can. This is my select statement. I'm thinking maybe it shouldn't be a select. Maybe it should be delete with the returning statement. This way I wouldn't have to block these anyhow. Right? Does it make sense? It does, but I will also have to match the not found transactions. This is something that I'll have to probably worry about later. Okay, so we have the squeal, like select squeal. And this is a prepared statement. Actually, I could do that afterwards. I'll have to set some values here, probably. Let's skip update. Execute batch. I think it's a batch statement though. I'm not even sure because there is a limit of how many rows you can actually supply here. This is something interesting to see. If I do the execute query, you know what? I'm just gonna probably. That might be a good thing for the. Yeah, what I'm gonna do, because yesterday I had a meeting with the guys from Windsurf, and they wanted me to try their product. What is not the best way to do that than this? See here, all of the changes were applied already, so it sees the batch processor. This is fine. I want my cache, the Postgres store. Let's see if this guy can warm up here. Hoping it can. Okay, tell me. It's me doing some prompt engineering. Let's see, which model am I running in here? Okay, this looks like a that's what I started. Okay, so I have this looks like a Gemini response because it's showing the thought process. Okay, this is nice. Okay, see here, this supplies the squeal array. Yeah, this is nice. But can you see that? This is something that I've started to like. So what Windsurf has done is like, hey, how do I do that? Sure, you can do this, 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 and that. And then it had retries and okay, this is the file I want you to validate. What's happening here? Okay, so it did get the delete requests. This is fine. All right, this I can accept. This looks legit. Then process batch records. This is something that's going to be nice. Okay, so I have here records key sets. That's fine. So I have the found requests. So it goes to get requests, but it doesn't have the transacted context in here. Okay, so this is something that I wanted to implement, but this guy, I don't think it understood my requirements. So if you look at this implementation here, it got the found requests, whatever it was, then it had matched the IDs, it's tried to match the thing here, and then process the message. This is fine, this is okay, it's unmatched. It also had done something. However, it didn't do that. In a transacted context. So you can still have a few, like a risk of duplicate processing of the message, or at least not be notified that you actually have duplicate messages. That's something that is worrisome, and probably I won't accept it. I will accept these changes here. Change the processed batch records to transacted SQL context. Let's see how the windsurf behaves with this. Mhm. Let's see how Windsurf is doing with this assignment. Great. Okay, so it does the pessimistic locking. This is fine. See here? Okay, this is what I try to do. So get connection, set auto commit. Then it got the select update. Then it did the matching. Okay, so for the prepared statement, then it did the array of these things. Yep. Squeal free. Okay, and it is the on match and the unmatched. Okay, this is reasonable. Do I get, okay, I supply the processor, which is going to be the batch processor. Yep, I think I should rename that for the clarity. And then it does the delete of these. You know what? Let's just ask them. Would it be faster if the query was a delete with a returning clause? Yes, it would be, but it doesn't hurt to ask. Okay, so it does this is something, I think it has a right. It's a good point because you can actually run into some problems when you don't have locked records, and you can, like, you still have to somewhat with to be deleted were expire for updates locked. Oh, okay, this is an interesting thing. So it does a for update statement, and it immediately deletes these requests, and it does return them. This is something, okay, this is something that I don't have not considered myself, but it then first statement then guarantees that these records will be locked, and then only if there's a match of these, it just does delete. So effectively, I'm running a single squeal statement for the whole batch, and it captures, like, it does a select for me, and then it deletes. In this case, I don't even have to worry about the auto commit level here because I only run a single statement. So this commit here can happen immediately. It doesn't matter. This commit here looks like it's not necessary. Okay, why is that absolutely crucial? I don't care much about the processing. Okay, so the reasoning here of this context, and I think it has the right. If it wasn't a if this was a true application, so if I wanted to make it fully resilient from the application side, and if it wasn't just a load testing tool, I would also keep the context of the commit of the transaction until I have finished processing all of the messages. But since this is a load testing tool and I can accept it being subject, like not fully resilient, so this is something that if this was an application, I would want to have all the messages processed. But if there's things going very wrong with this test, I can accept messages being gone because I will have to retest the whole thing again, anyways. So I can accept it not doing the commit after it had finished the processing. The reason behind it, and this is something that's the reason behind it is I want to minimize also the footprint and the number of connections I'm having to the database and number of concurrent transactions against my Postgres. So this is a resource saving. I know that there is a risk of losing these messages, meaning processing the messages when if something goes wrong, but this is not, and the load testing tools do not have to have like 7 or 9 nines of the availability or the resilience. And if there's something wrong with this processing with those messages, um, then this will be logged by some exception and will have to be like most of the cases the instead of retrying, instead of trying to reprocess these messages, um, they would have to be just no, the test would have to be repeated, and this is something that is unavoidable unless you want to pay additional fee for the resources. I'm happy with just removing this whole commit statement and not do any commits or rollbacks. I don't have to close the connection though here. I don't think it's necessary. I'm using try with resource anyways. Okay, it doesn't do try with resource. When I try to paste in that, I've used the try with resource, which is using any resource that is like auto closable interface. This is a Java feature. I think it's Java 9 thing here. If you specify like this, it is already trying to force, and it just it's a try with resource, so you don't you specify this resource in the brackets, uh, and it automatically closes this thing here. So it has to be auto closable or closable implementation somewhere, and then it just tries to close this resource later. Okay, so this is the connection. We're getting it. Auto commits. So it can be true. So it just stays here. I don't have to do any rollbacks. I like this statement here. I like this query. So we do locking and we do delete with the returning statement. This is fine. This is okay. So I can just lock these records immediately and then just return it. While keeping the atomicity of the transactions. Still crucial. I cannot just do delete of those because you could attempt deleting the two records with the same query at the same time. At least I think that's the case. So it's better to be safe here and use this select for update skip locked. This expired thing here, I don't think is actually required. This expired field, I'm not going to use in that, because the expiry of the message for me would mean that it would just be gone. and this will be handled elsewhere. I don't want to set an expired here. I just want to lock this record for any processor, be it I have to have some trigger to lock the record. First trigger would be to have a response on this for this particular request. This would lock the record. The second trigger would be to add some external process to time out this request. In any case, I would only and the other one would be an attempt to lock it, but if it doesn't find anything, it's going to be problematic. Ah, my little kid just entered here. Hey, Tata. So, so my little kid just entered the room. And he's going to probably break a few things. Whoa. Oh. Huh? Okay, so I like this idea. Huh? I like this idea, this implementation. So this could be a bit okay. So it uses my columns, it uses my request types, so fund requests. Okay, and it does so automatically. So it says the array here, executes the query. Now I have to go really line by line with whatever these tools produce. This is something that I found. No, they make up some problems, they make up some codes, and it gets harder to trace that afterwards. Okay, so this rollbacks and commits, they don't belong here. Okay, it goes with a try and catch, I guess. Glue array. Okay. This guy, okay, this can have a GUIL exception for whatever reason. This error handling of this is another story, so I'm fine with losing the whole transaction context, but I'm not fine with. Oh, sorry guys, I have to give my. All right, we're good to go again. So this here, this is the correlation, this is an array. The still throws, okay, and use the try catch with this GUIL exception. Every part of this code actually can throw a GUIL exception. So I'm not sure, maybe. If I do try with resource. Okay. Why is that? Okay, now can I accept this thing here? I still have to handle this one exception here. Quick fix. Okay, and this can capture the GUIL exception. If something goes wrong in here, this process, that is a Yeah, I'm just gonna throw a runtime exception at this part. Okay, I kind of like this. I can accept this change here. So, how the final implementation works is, again, we get this one connection here. This is fine. It's going to be closed later. That's okay. We have a with statement. So this piece locks the records. This piece deletes them and also returns them. So we do it with a single squeal query. This is fine. I'm not sure what the size. Maybe I should be limiting the size of the of those somehow. And then it's not a big problem really. So then we have the query execution. We're submitting the UID array. So this is going to be changed from the taken from the key set. This is the set of keys that are in the response records. This is fine. This is totally acceptable. And then we have a matching and processing. Maybe there is a matched, maybe there is an unmatched. This is totally fine. So we can specify in the batch processor unmatched and unmatched response. So there's an unmatched here. We can have a different behavior, and unmatched we can do some processing. This looks like a solid piece of code here. With this, however, I think it's just going to be more straightforward. We can do some map filtering or stuff like that, because the in-memory store, this is something that this is just a simple map, really. So there is nothing complex here. I'll have to just do some checks and some. I'm not sure whether an index is due here. It really depends on how many in-flight messages will be there, right? So of course it's a map, so you can just access to this map per record is like O1 really complexity. Nothing scary, nothing problematic. Okay, I suppose this would be it for today. I'm gonna have to run a few tests later and do some actual implementation of this batch processor. This is something that I think would be the most important part, because I need to make sure I can match these and produce errors and produce the logs, even because it's not that easy for Gatling to produce custom metrics and custom volumes here. I'll have to make sure everything works fine. And also, right now, since I'm changing the behavior of this thing, and I'm flipping the behavior of the application a bit, this might be something like I'll have to match these records somehow somewhere in the processing. So I have the consumer right now, the structure here. If for my consumer, this forwards each of the message right now to the message processor router, and then the processor router handles singles effectively everywhere. So I think I should do some changes. I should do some amendments for it not to accept only the singles, but also the whole batch. This will make this thing more robust, because well, at least the consumer actor, it would consume in batches. Like even if it's a single batch of one, it is still a batch. So this is something that I'll have to fix, probably change later. It's not the same for MQ protocols. So polls from MQ are usually with a single message. The batching is something that we can handle internally in the application, but it does affect and it skews the results of actually real-time messaging measurements. So again, guys, thank you for watching. Thank you for staying with me for that long, and we can continue tomorrow. And have a nice day.